Now, this is quite a lengthy. Next question. Okay, now let's start off with given the gradient function. Okay, gradient function. But to find the equation of the curve, we have to find the y function. In other words, we have to go backwards. Given the gradient function, you have to integrate. That means the opposite of differentiation. So you want to find, this is already differentiated. What you want is you go to the reverse direction, which we call integration, and you obtain the y function. Okay? Now, you haven't gone to integration yet, okay? But then I can tell you the y function is this, okay? Now, what you do is you go and differentiate this function over here, this one. You go and differentiate this whole thing, you will get back this. So the integration, that means the reverse of the differentiation, you will get this. Okay, but remember when you integrate, you always plus a constant. Why? Because if you differentiate, this constant disappears. So when you want to go in the reverse direction, this constant cannot be found immediately. You have to use some given information in order to find C. So this step from here onward is what I do to find the value of C. Now I know that it passed through this point, so this is a y function. So I can take the phi as the y here. I can take the x, which is pi over 4, and I substitute. Okay, I simplify. Then finally, I will get actually c equal to phi. Okay, then the y function become 3 sine bracket 2x plus pi plus phi. So that is the y function. Okay, so this is the answer for part 1, the equation of the curve. Now, next we have to find the x-coordinate of the stationary points of the curve. So what we're going to do is, we're going to use trigonometry as we done earlier. First, we have to convert this domain, okay, into similar to this here. Okay, so what we do is take the given domain, multiply by 2. So we get 2x. So this is pi over 4 times 2, you get pi minus pi over 2. This is 5 pi over 4, you times 2, you get 5 pi over 4. You times 2, you get 5 pi over 2. Then remember, you have to add pi over 2 here. So we're going to add pi over 2. Every term I add pi over 2. And I simplify, I get 0 to 3 pi. Okay, so the domain that we're going to work on the angle is from 0 to 3 pi. Now, let's go and look for the basic angle. When dy at the stationary point, dy dx equal to 0. Okay, simplify further. You got 0 equal to cosine 2x plus pi over 2. So the basic angle is arc cosine. This bring over, we can arc cosine 0, which give you pi over 2. How? Now, if you look at a cosine graph here, which I explained to you before, cosine equal to 0 is 1, cosine pi over 2 is 0, cosine pi is minus 1, cosine 3 pi over 2 is 0, cosine 2 pi is equal to 1. Okay, you got it? Now, so basic angle for cosine arc 0 is the first angle that meet the requirement is pi over 2. So you write pi over 2 here. Beside that, you understand. You also notice it also equal to 0 when 3 pi over 2. When x equal to 3 pi over 2, it also give you 0. So this is the second angle you have to consider. Now, where else? How wide can we consider? Now, the next thing, you look at the domain over here. Here is up to 3 pi. That means it's 1.5 circle. That means we we have to consider angle from here, 0 all the way, okay, all the way until here, 360 degree, 2 pi. But that's not enough. You have to go for, after you reach the 2 pi here, you have to go for another round. Sorry, half pi. Pi is up to another 180 degrees. So here, we know, we replicate this, this also becomes 0. Okay, this becomes 0. So this meets the requirement of the basic angle. So this point here is actually 2 pi plus from here to here is half pi, pi over 2. So it's 2 pi 360 plus another 90 degree, which is half pi. So total is 2.5 pi. So with this as the domain set up, you got 3 angle which meet the requirement, which is pi over 2, 3 pi over 2, and 5 pi over 2. Now, bring this constant pi over 2 to the other side. Pi over 2 minus pi over 2 becomes 0. 3 pi over 2 minus pi over 2 become 2 pi over 2 become pi. This one become minus pi over 2. This is 1 pi here. This is 5 pi. So then with 4 pi over 2 will give you 2 pi. Okay, now, then bring the 2 from the x. So you divide, you got 0, pi over 2, and pi. Okay, so this is the second answer. This is the x coordinate of the turning point. Okay, now, next is to find the equation of the normal to the curve at the point on the curve where x equal to 3 pi over 4. Now, to form the equation of normal, normally we have to use this. Okay, this y1 and x1 is the point where the normal pass through, but also the point where the tangent pass through. Okay, then this m2 is the gradient of the normal. Okay, now we know that the normal pass through this point, so the x coordinate is 3 pi over 4. Okay, but we have to find the y coordinate. So the first thing you have to do is you're going to substitute we're going to substitute, yes, from here onward. Okay, we're going to substitute x equal to 3 pi over 4. Taking the y function, you substitute x equal to 3 pi over 4, you simplify everything, you got sine 2 pi. And you know sine 2 pi? Okay, let's look at this. This is sine 0, 1, 0, minus 1. Sine 2 pi is same as sine 0. So this whole thing sine 2 pi gives you a 0 value. So 3 times 0 is still 0. So y is actually equal to 5. So the point here where the normal pass through is 3 pi over 4 for the x value and 5 for the y value. Okay? Now, then you also want to find the gradient of the tangent first before you can find the gradient of the normal. So to find the gradient of the tangent, you use the tangent function, which is dy dx, okay? And then you substitute the point 3 pi over 4 inside. And you should simplify, you get 6 cosine 2 pi. 6 cosine 2 pi, let's go back to here. Cosine 2 pi is here, which is same as cosine 0, which is 1. Okay, 1. So therefore, 6 times 1, so is equal to 6. So this is m1. This is m1. This is the gradient of the tangent. Okay, now, we know that m1 times m2 equal to minus 1. So I want to find m2, which is the gradient of the normal. Is m1 times m2 equal to minus 1. Okay, so I want to find m2. I already know m1 from here, which is 6. Okay, which is 6. So what I'm going to do is I'm going to bring the m1 over here. So become minus 1 over 6. Now, So we have the available information to form the equation now. First, we have the point, the xy coordinate where the normal part, okay, which is this point here, 3 pi over 4, and y, okay, which is 5. So I'm going to substitute the y, 5, and the x is 3 pi over 4, okay, and equal to minus 1 over 6. And then what you have to do is you're going to bring this whole thing up. Don't cross multiply, just bring this thing up. So it's minus 1 over 6 times bracket x minus 3 pi over 4. Bring the 5 to the right hand side, you plus 5. Open up the bracket, you got minus 1 over 6 pi plus minus times minus become plus. Okay, now 3 pi over 4 times 1 over 6, 3 and 6 will cancel, become 2. So 2 times 4 become 8. And then the 5 will be here. Okay, so that's it. So the function, the normal equation become y equal to minus 1 over 6 plus pi over 8 plus 5. That's it.